Hey guys, welcome back to the RCA RR-359 restoration project. Let's get right to it. In this video I want to experiment with replacing the burned out high voltage transformer, which consists of primary and 3 secondaries. It is on the schematic. So we have a high voltage secondary, needs to be about 5,000 volts AC, and we need 2 filament windings, one for the 878, one for the 879. This guy is the main high voltage rectifier. Filament supply on this is 2.5 volts at 5 amps. This is the focus rectifier. It's about 2.5 volts at 1.75 amps. And because both of these are directly heated, you've got high voltage on the filament, so these filament windings need to be insulated. Alright, I'm not going to find a single transformer that will accomplish all this, or it's extraordinarily unlikely, so we're going to do it with separate transformers. Neon sign transformer, 5,000 volts, that's our high voltage, and for the filament, I propose using this for one of them. It's 2.5 volts at 10 amps, and insulated to 10,000 volts. A bit overrated, but you get what you can get. Somewhat limited market for these days, so nobody's really making them anymore, so I had to go on the surplus market. Now I did end up getting 2 of those, and if they all fit, I would just go with this and we're done. But I'm pretty sure these are not going to fit inside this can. These guys in particular, because they're kind of beefy. It looks like they would fit, right? But no. As I mentioned in the previous video, it's maddening with so many of the things I've tried using with this set where they're 90% of the way there, but they just don't quite fit. They just don't quite work. So this, not like that. Okay, cool. Let's stack them this way. Too tall. So I've tried various combinations and they're just not going to fit. Plus, I don't want to cram them right next to each other. It'd be nice to have a little bit of spacing between them. But for sure, 2 of them will fit. It looks like that would go right too, but I think that, because remember, these tabs need to get bent over, so it's not like we have this full height. We have the height up to about here. And if we do this, I think this is just, that might work, but I don't think so. If we go this way, yeah, it's like 1/8 of an inch too tall. But I think if we do this, this will work. Yes, that will fit. So that gets there of those 2. Okay, well, we need another one. There are smaller ones. I could get, at least there's one of them on eBay, a used kind of crummy looking one, 2.5 volts, rated for, I think, 5,000 volts. Should be pushing things a little bit, but they're smaller. And if I could track down 2 of those, then at least one other restorer has fit 2 of those inside with one of these. So that's an option too. But what we're going to try doing right now is something I mentioned in the last video, which is to wrap a few turns of wire around this primary, because we've got some space here, and see, can we steal some power from this? I already got one comment being very skeptical that that would work. It's saying that each turn would only be about 100 millivolts. I know that's not the case. I literally was just reviewing another restorer who did this, and he used that trick. I think he said he had to use 10 turns of wire, but he wasn't quite sure. He's also in Australia, and he had to re-engineer this a bit for the voltages, and his set was he only needed 2,500 volts, not 5,000 volts, so it's a little bit different situation. Also, I reread what he did. I mentioned there's a gap in these. He enlarged the gap. He didn't close the gap. These are designed to have an unloaded output voltage that's higher, and then it drops down, because they're meant for neon signs. You got to get the gas ionized and going, and once it does, you can drop the voltage down. So we want to do a couple things with this. But first off, what I want to do is rig up primary to this, and I need to safely keep these out of the way. Maybe I'll put some load resistors on these, because I want to verify what the output voltage is, but of course I don't want to get shocked or anything. So, and I want to wrap some turns of wire around this and find out how many turns per volt with a load do we get. So here's our target. 2.5 volts AC at 1.75 amps. I need to figure out what that load would be. It's about 1 ohm, but a little bit higher, 1.5 ohms, something like that. What load we need to put on that. So let me rig up some parts and see what we can do. Alright, let's give this a try. I have 4 turns around the primary, 1.5 ohm, 5 watt load, and just to simulate a little bit of a load in the high voltage output, I strung together about 15 mega ohms, and I've got an AC voltmeter across that resistor. So, see what we get. About 0.7 volts. So, yeah, we're going to need a few more turns. The guy who did this, I think he said he used 12 turns of wire, but he had to rework his transformer a bit, as I mentioned. So, let's see. So we need about 3 times that much. So, we'd need about 12 turns of wire around that core, which we can do, but I'll need to be careful about the wire. So we won't have that much current, 1.75 amps. And it's going to the 2x2 rectifier, and the focus output is about 1.5 kilovolts, so I don't need like 20,000 volt rated wire or anything this thick, but I need something that's a little bit better, I think, than the standard insulated wire, which is good for 600 volts. I need something that's about 3 times that. I don't think I have anything in the workshop that's quite appropriate for that. I scaled up the test a little bit. Got about, I think, 8-9 turns on there. And 1.5 ohm load again. Let's give her a try. So we're close. We're a little over 1.5 volts. So we need 1 more volt. So we need a few more turns of wire. So the challenge now, yeah, this will work fine. We just need to find wire that's small enough that I can get 12 or so turns around there that can handle 2 amps safely and be good for about 2,000 volts. So it's just like everything with this project. Everything is so close, but it occurred to me, I'm making this out more difficult than it needs to be. See, I don't wind transformers very often. It's not the insulation between the individual windings we need to worry so much about. It's the insulation between this group of windings and the primary and the metal core. We don't want these windings to arc between this metal or the primary windings. So we can use just enameled wire. Got some stuff here. It's a bit thicker than we need. Heavier gauge, we need probably 18 gauge. But even so, it's thinner than this white insulated stuff. And it probably would fit on there. And to insulate it from the primary and the core, we can use some Kapton tape, which has fantastic properties, including dielectric strength. It's something like 7,000 volts per layer of tape. So if I take all this white wire I added off, wrap a couple turns of this around, I'll probably do 3 or 4 just for safety's sake, because it's very thin stuff, and then put the enameled wire on, and then wrap some more tape around it. We should be good. Maybe secure it all with a little hot glue or silicone, something like that. Now, threading the tape through won't be particularly fun because, well, I can't take the core apart without taking these rivets out, which I'm not going to do, so I'll have to thread the tape through and around, but we can get it done. Alright, so assuming that's done, what do we want to do next? Well, I want to rig up the entire power supply, including the rectifier tubes. So this secondary winding is going to power this little guy. It's a 2x2, also known as a 879 tube. So the fatter pins here, those would be our filament. And the rectifier for this secondary is going to be an 878 tube, which is this guy. This one's labeled as an 8013. Some of these tubes went by different designators over the years. This filament will be powered by one of these guys, and it rectifies this high voltage secondary. This guy rectifies the high voltage secondary on a transformer that's still on the power supply chassis. It's smaller. It's something like a 1500 volt transformer. So it's not this guy down here. It's this guy over here. The final output of that is something like 1350, 1550. I can't really quite read that too well there. Let's go to the schematic here. Kind of worn out, so I can't quite tell. But it's less. It's less. It's under 2,000 volts for sure. So how can we do that? Well, we're going to need to hook these wires up to these pins, so we're going to need a socket, right? And here's the thing. There'll be high voltage on these tubes, especially this guy. We can't just use plain old simple phenolic type sockets like this new one I picked up. Probably wouldn't be sufficient, certainly not for the higher voltage one, and older ones that are just made out of a couple sheets of phenolic riveted together. No, that's not going to cut it. So what did they use in this set? What did I find inside that high voltage box? Well, a couple things. One, unfortunately, it cracked. So here's half of it. The other half is still mounted in the chassis. This is a sheet of something called Mycalex. The whole thing is about yay big, and it has both tube sockets mounted on it, and the tubes plug into this. So it's definitely a very unique component to this chassis. I mean, you're not going to buy this off the shelf anywhere in any surplus market or anything. It was tailor-made for this. So it came out to about yay big, and there was another one of these sockets over here, and there's a screw terminal. That's where you pick off the final output voltage that goes up to the CRT. It's unfortunate it broke. So what am I going to do about the fact that it broke? Well, I'm going to try to glue it back together. There are some other possibilities, though. One, I could get a 4-pin socket that's made out of, well, I haven't been able to find any that are made out of Mycalex exactly. Well, let me take a step back a little bit. This material was invented in 1919. It's a ceramic that is ground up mica in it. That's where the name comes from, Mycalex. The company that makes this is still in business. I can buy a sheet of this. Same thickness, an eighth of an inch thick, from their website. I can order one right now. But there's an issue. You can only buy it in one size, which is about 4 times or more bigger than what I need, and it's about $800. And then I would need to machine it. Now, they say on their website one of the great properties is that it's machinable, drillable. However, when I went on to a machinist forum, they said, yeah, but it takes skill, takes the right bits, you have to know what you're doing. It's kind of like drilling through, well, ceramic, glass. It's very, very brittle, which is why this cracked. So you're going to need specialty bits. So you're going to need constant water cooling to flush out the drilling, the tailings, I guess they call it. And it's not just holes. You can't see it so much here, but there are some slots in it. But theoretically, yes. And I'd have to remove these. It's the same type of socket pins that we saw on the other sockets throughout this set. So they bought it, they got a sheet of this material, and they drilled holes in it, machined it, and then they mounted the tube socket pins directly to that big sheet. So, if I get this whole set working beautiful, and I really, really want to replicate that, what I was thinking what I could do if money was no object is I can buy a sheet of it, and I can hire a machinist, outsource it to a shop that knows how to work with this and could make this and fabricate this for me. So it's, we have options. But here's another option. Surplus Sale in Nebraska. I went to their website, and I was shocked and amazed to see that they sell this, a Mycalex sheet with 4-pin holes. And it's a piece about yay big. with 2 mounting holes on it. And I ordered up a couple of them, $15 a pop. When those arrive, I'm going to rig it up with all this stuff up on the workbench. And if I had to, they're smaller than this with the 2 of them together, but I could use phenolic or some other material to build up a larger piece and then cut out sections and mount the Mycalex sockets within that. Here, I'll show you material I have in mind. Here we go. It's G10 fiberglass sheet, which is really excellent stuff. Think of it like really thick circuit board material. This is exactly the same thickness as this Mycalex. So if I wanted to, I could also take this, and this I could, I think, handle myself and drill it with the proper bits, and I could replicate this entire piece using this material if it came down to it. The interesting thing too is you can see where it's on the edge. If you were to like grind or sand down this black shiny material, the color inside is actually pretty similar to this Mycalex stuff. But anyways, so I'm going to attempt to glue it, I figure. Like I said, it's a pretty clean break. And it's not surprising it broke where, well, this is screwed down to the steel. And there was some stress cracks. I think from over the years, tubes being pulled in and out, the screws maybe tightened down too much, but also this is where there were some slots machined in it. And that's where it broke along there. But the brakes are not near any of the tube pins. So I was thinking if I put the pieces close together and wick in a little bit of super glue to stabilize it and then feed in some high quality epoxy, I could probably salvage this. It's an interesting material. When I first saw it, I thought it was slate or something like that, because it is very stony seeming material. But this also has fantastic properties, which is why over 100 years later they still make it. So when those 2 sockets arrive from Surplus Sale, Nebraska, I'm going to pop these 2 tubes into them and wire this stuff up. The filter chokes for the high voltage supply are on the main chassis, and I don't particularly want to unmount them, and I don't really want to experiment with the main chassis because it's huge and heavy and don't want to break anything else. That would be what these 2 coils are. But I figure I could use a resistor, make an RC filter rather than a pi, I have high voltage capacitors, so we can do that and then use a resistor instead of a coil there. It'll be similar. And then we can put in our bleeder resistors and, hook this thing up as close as is practical to simulating the final circuit. Get it all up there on the workbench, simulate loads, and see what the output voltage is. Also wanted to mention that my mentor on this project, Daryl, sent me a couple 878s. He had some spares from his collection, and there's one I wanted to show you what came in here, aside from being a tube and wrapping some nice Excelsior padding. Nice tube, United. So this one says 878 on it instead of, what does that other one say? 8013. I didn't notice this before. They're actually shaped a little bit differently, too. The top cap is considerably different. Huh. Which one's older? Which one's closer to what it was really originally in here? I don't know. That's X-ray shielding down there. Well, we'll try them both out. But I also wanted to show you this, because these are military. They just came with some interesting paperwork. Bureau Ships Naval Department Radio Division. Official business. Penalty for private use to avoid payment of postage, $300. You better be careful. So if you get this tube and there was a problem with it, you could fill this out and mail it in. And there's a whole form here with carbon. You can make a carbon copy. You get this in triplicate. We got a blue and a pink sheet. And you fill this out. Say when it arrived, when it was installed, when it was failed, what the failure mode of, how many hours were there on the filament, and what was the plate voltage, the grid current, the screen current, water temperature, if it's water cooled, operating conditions at time of failure, in other words. January 1942, life hours, 1,000 hours guaranteed, United Electronics Company. So yeah, that matches the tube. So United. So this is all the real deal, the original paperwork from World War II. Very cool, very cool. So I'm very happy to have that. So we'll see. We'll try these tubes out. You warned me that some of the ones you buy off eBay, they can be duds. So we'll give them a whirl. Which, yeah, it's another reason why I want to do all this up on the workbench. Is let's cobble this all together, make sure everything works before we really commit it and start wiring everything up for sure. But there we go. I think we're off to a good start here. I was thinking through my stash of enameled wire, and it's all on the thinner side, like for rewinding speaker field coils, that kind of thing. And this is a little thicker than I'd like to use, so I think I'll order up some that's maybe 22 gauge. While we're on the topic, let's talk about wire a little bit more. So I need to replace a bunch of wiring in this set. There's a lot of crumbling rubber wire, and there's some cloth wire. Now, I mentioned this earlier about the wire I typically use, this stuff. It's, I think 20 gauge, 22 gauge. And it is, yeah, it's 22 gauge. And I have an assortment of colors, and I can match up to what was originally in the set, because I know what the original colors were. It's on the wiring diagram, like so. So yellow, yellow, blue, yellow, green, etc. So make it all nice and pretty, but there's printing on the wire. Now, I got a tip from some of you guys about using acetone mixed with some alcohol to remove the printing, and yes, absolutely that works. So I did a suction on this and removed all that printing. Yeah, absolutely beautiful. So thank you for that suggestion. Now for the cloth stuff, pulled out my stash acquired over the years, various radio projects. So we have options. One, I have some nice 2-conductor stuff. We could use some power cord, this kind of stuff. Some nice woven nylon cloth covering with line cord inside. And for the other, some of the stuff I got I'm not crazy about, because it's basically the same as this plastic insulated wire that I just had out here, and they just put cloth over it. The end result is it's really thick, even though the wire gauges and all that thing is 20 gauge stranded, because it's double insulated. It's plastic, PVC with cloth over it. There's something else called pushback wiring, which is a lot closer to what they used in this set. I call it pushback because you don't really need to strip it. You can just push the insulation back and expose some wire. This is a little bit harder to find. It's solid core, just like the original stuff, which means when you route it around something, it holds its shape, which makes it nice to work with. Problem with this stuff is it's unrated. So this stuff, I'm pretty sure is 600 volt, because they took 600 volt modern plastic insulated wire, just put cloth over it, so it retains the original voltage rating. This stuff, it's unrated, meaning how much voltage is it good for? We don't exactly know. Now this set only runs on a few hundred volts. The highest potential out of this is something like 300 volts, but that gets divided down, and most of the set runs on 200 volts or less. I'm pretty confident this can handle that, and I have a decent assortment. As I said, most of the wiring's plastic, but for where I need some cloth wiring, I have some pushback, and in a pinch I can use this. Not sure if you can get pushback wiring now. The boutique guitar amp restoration places tend to have some cloth wiring, so if I need some, I think we're on pretty solid footing with doing the rewiring, between wiping off the printing on the modern wiring and my stash of cloth covered and the few suppliers that are out there that still make it. I think we're in good shape with that. Alright, I want to do one more thing in this video. Let's clear some space here before I break one of these precious tubes. And that is to open up a capacitor, one of those metal cylindrical ones, and explore some techniques for restuffing them. I'm going to use one that's not original to this set to experiment with first. I just got a comment from one of you guys on my last video about uncrimping rather than cutting them open, and that's something I hadn't considered, so let's take a look and see if that's even possible. Make sure I measured their wire, and I think it's more like 16 gauge, so I just ordered up some 20 and 22 gauge enameled wire from Amazon, overnighted it. It'll be here tomorrow. I figure I'll also be using some of that to wind coils for the tuner. And I think I'll be using some of that Garolite tubing, I should have mentioned that, that I got for making replica dog bones. I'm also going to use some of that as a coil form for the tuner. Alright, lastly, let's look at caps. So I got 4 of these that are going to go in the set, and I want to rebuild them to experiment with. Let's take one of the replacements that was installed. I got a comment from a viewer about, hey, maybe you can fabricate a tool to make uncrimping the seam easier. And yeah, conventional twist lock type caps are sealed on the bottom by rolling over, crimping the aluminum can, and if you're careful you can uncrimp that, pull out the insides, put new stuff in, and recrimp it. That's not how these are made. These are like an extruded aluminum tube, and they roll it over, put threads into it, crimp it. This is all one continuous piece of aluminum, except for this top cap. So I took a close look. I thought, oh, well, maybe the top is knurled over, and you can unknurl that and pull the cap off. No, this is one solid piece. But there appears to be a gap down below. So what I think they do is, this is a separate piece. I think they put it into some kind of press and press it down onto the cylinder while also pinching this in. So honestly, it looks to me like, now I don't know how, like this top cap may very well be indented and then this goes into it, because I was thinking, oh, I'll take some pliers and grab this and maybe I can kind of unscrew it. I got a feeling that it's would be a little bit harder now, because I've seen some of these where the top is bulged up, including this one possibly. So I think a lot of force can build up in here, and this top ain't coming off. The metal starts bulging out, and eventually they explode, basically, if they don't have vent holes in them, or the bottom blows out. So I don't think I'm going to be able to just grab this, twist it, and have it come right off. What I've done in the past is very carefully cut around here. When I say cut, I don't mean with a hacksaw, although you could do that, or a Dremel cutoff wheel. This is aluminum. It's pretty soft, so what I've done in the past is taken a brand new, very sharp utility knife blade, and even not in the holder, and just go in here and just do this. And eventually this will cut through the aluminum enough you can get the top off. But it would be cool if I could kind of open it like a bottle cap and just pop the top off and then snap it back down. But I don't think it would be that easy. So that's the trick, I think, to this, is where do you want to cut that? Now it seems pretty obvious if I cut it here at the shoulder, the top would come off no problem. But when I seat it back down, I'm going to lose kind of that effect. It'd be nice if I cut it right underneath that lip. But if I do that, I don't know that I'm going to be able to pull the top off. I don't know if it's going to really accomplish anything. Say, I have done this before, but it's been a while, and the cans weren't quite like this. It seems like that. It's just so tempting. There's a gap in there. They get something in there and kind of start prying, but of course it's aluminum, it's soft, it's going to dent in. I don't want to do that. Well, it's interesting that it's very knurled on the inside. I wonder if that had something to do with like the press they used to press fit this down into there to leave marks on it. changed my mind. Tell you what, we'll do this in a separate video. This video is already long enough. Let's do this as a whole dedicated separate video. So I think this will be of interest to a lot of folks. So I'll do my research, and if any of you have tips, tricks, suggestions on how to do it, love to hear from you. See, this is one that we want to restuff, we'll experiment with. But they both seem to be made the same way, where the top cap is a solid piece. It's a little bit of a gap, and it sure looks to me like they put these on the cylinder and then crimp the cylinder down. And it's kind of underneath that top cap, so you can't really get in there and get at it and start doing anything. So that's the challenge. How do we pop one of these open without really marring it up and then reseal it? That's it for now. Thanks for watching.